Chapter 8, Lesson 4. Essential question, how can different fractions name the same amount? And we're fully into equivalent fractions. So we're using our models still. You have used models and number lines to find equivalent fractions. Multiplication can also be used to find equivalent fractions. Fractions that have the same numerator and denominator are equivalent to one whole. So if you look, what that means is if you look at the chart here, if they have the same numerator and denominator, 2 2s, 3 3s, then that means they're equal to one whole. So that's what you're seeing here on the number chart that I made. Okay, that's what that meant. Example 1. A recipe for spaghetti and meatball calls for 3/4 pound of ground beef. Find two fractions that are equivalent to 3/4. One way is to use models. So if you've got your models from your kit, we model 3/4 by putting 3 together. And then we can use 1/8 tiles and 1/12 tiles. So you just keep putting 1/8 tiles down until you get to the lines are equivalent on both sides. And then you'll see the 1/8 tiles are smaller than the 1/4 tiles, so there are more of them. That's an important thing to realize. And the 12th tiles are smaller than the 4th and the 1/8 tiles, so there are even more of them. That's an important concept to remember because a lot of people think, oh, 1/12, 12 is bigger than 1/8, so therefore 1/12 is bigger, but it's actually the opposite because these are smaller pieces of the whole. So that's important. Now here's the multiplication method that we've kind of hinted at in other problems. Multiply the numerator and the denominator by the same number. And that's because, remember, 2 2s would be the same as one whole. And that's why they've got the outline that looks like 1. And that would be the identity property. When you're multiplying by 1, you're going to get the same number. So if we take 3/4 and we multiply the numerator and denominator by 2, 3 times 2 is 6, 4 times 2 is 8. So 6/8 and 3/4 are equivalent. Now this next one we're still multiplying by one whole, but instead of multiplying by 2 2s, we're multiplying by 3/3. So they're going to be equivalent, they're just going to have different numerator and denominator. 3 times 3 is 9, 4 times 3 is 12, so 3/4 and 9/12 are equivalent. So two fractions that are equivalent to 3/4 are 6/8 and 9/12. So this is where knowing your factors and multiples comes in really handy. If you know that two multiples of 4 are 8 and 12, then that helps you figure out which number tiles to pull from. If you're looking at all your number tiles and you're saying, oh, is 5, like over here, I've got 3/4. 5 isn't a multiple of 4, so there's nothing to line up. 6 isn't a multiple of 4, so there's nothing to line up. 8 is a multiple of 4, so that lines up. 12 is a multiple of 4, so that lines up to our red line that I've got here. Okay. Now on the next page, the example uses just multiplication, but if the multiplication is a struggle for you or you're not clear on it, you can definitely still use the chart or the fraction strips, whichever works for you to get the correct answer. You can use multiplication to write a fraction with a denominator of 10 as an equivalent fraction with a denominator of 100. Okay, so they've got their charts that have the denominator of 100, but they're telling you you can make it also a fraction of 10 as long as the numerator is a multiple as well. Liliana has a container of dry beans. The table shows the fractions of each type of bean. Which type of bean shows a fraction that is equivalent to 3/10 of the container? And we've talked a lot in class about the place value and when you've got a 0 on top and bottom, or you've got a 0 in both parts of the multiplication equation, what that means. So hopefully you can see that pretty quickly, but let's walk through. Each fraction in the table has a denominator of 100. Use multiplication to find which fraction is equal to 3/10. Okay, so we've got 3/10 equals 3/10 times, and in order to get 100 as the denominator, that's why we're multiplying by 10. 10 times 10 is 100. 3 times 10 would be 30. Sorry for the horrible writing. So 3/10 of the container has, according to this chart, 30 hundredths lima beans. Oh my goodness, I don't know why this is not writing so well. Lima beans. Okay, now on the guided practice it says, write the fraction for the part that is shaded, then find an equivalent fraction. So that's why they've given you 2 lines. You're showing the fraction that is here and an equivalent one. And hopefully this one goes really quick because we've done this a bazillion and 2 times in class. This one is a little bit different because only one section is shaded. So you're going to have to divide each of these sections into either 2 or 3 or 5 or however many you want to make an equivalent fraction. So if you wanted to divide it, you're going to try and make it as equal as you can, but again, we're doing the best we can here. So if I wanted to divide it into 2, each of these sections into 2, as long as I do each section into the same number of pieces, then I can see what equivalent fraction that is there. Okay, so continuing on in your independent practice, these first problems are similar to what you did on the guided practice. You can divide these shapes, each section, into the same number of pieces and get your equivalent fractions. It's only asking you for the fraction that's shown and one equivalent, but bonus points if you find more than one. Anyway, circle 2 fractions that are equivalent in each set of fractions. If you know your multiples, this is going to be much easier for you than if you're still struggling to know counting by 4s and counting by 6s and things like that. So this is, even though it's fractions, knowing your multiples and being able to count by is a huge benefit to getting these done, these equivalent fractions here. It's also going to help to see here 4 times what is 8. If you can identify what the multiple is or what the factor is that gets you to 8, you're going to get your answer much quicker because you're just going to multiply the top by that same thing. So that's how these are done. What did you multiply this by in order to get this? Do the same to the bottom, and then you've got your finished fraction there. Okay, when you get to your problem solving, 17 and 18 are pretty much just equivalent fraction problems, but number 16 is a little bit different, so I want to go over that. Female deer called does usually have 1 to 3 young at a time. Young deer are called fawns. The male deer, called bucks, grow antlers in the spring. Suppose 10 deer are traveling together. If 4 of them are does and 3 are fawns, what fraction represents the number of bucks? Write another equivalent fraction that represents this number. Okay, so you're taking out the total number of deer, which would be 10 tenths. So let's write that. So you've got the 10 tenths, that's the total number of deers that are traveling. 4 of them are does, so we're subtracting 4 from the whole. And 3 of them are fawns, so we're subtracting 3 tenths from that. Then you'll get, once you subtract this, then you subtract this, then you'll get the fraction represents the number of bucks. And then you're going to find an equivalent fraction that is the same as that fraction. You can either use your chart or your tiles or multiplication to figure that out. Or you can use division as well for that. Now you may be, on this one, you may be thinking, well, why don't I just do 10 minus 4 and get that answer and then minus 3? Well, again, this is a simple problem that we're starting out getting used to fractions so that when we get to the more complicated problems, you're able to do these steps without having to add on multiple layers of complexity at the same time. So just practice it this way, get used to it, get familiar and comfortable with it, and then when we get to the more complicated things, this won't be a challenge for you to add on to the other challenges. So hopefully that is the only difficult part in these. Fraction is equivalent to 25 hundredths. You can divide or multiply there. How can you check to see if 2 fractions are equivalent? Explain. You've got at least 3 different ways that you've been shown how to do this, so all you have to do is write one.